Hello everybody. In this video, I am going to talk about a regulating valve used in some refrigeration systems called the evaporator pressure regulating valve, commonly referred to as the EPRV. These valves come in various sizes and shapes, both mechanical and electrical. Let's explore what this valve does and how it works. First, where should it be installed? The EPRV must be installed in the suction line between the evaporator and the compressor. In what applications do we need to use this valve? This valve should be used in applications where the evaporating pressure, and consequently the evaporating temperature, must not drop below a certain value. I will provide an application example at the end of this video. Now, let's see how this valve ensures that the evaporating pressure does not drop below a set value. In this system, let's say we need the evaporating pressure to not drop below 3 bars. Therefore, the EPRV is set to 3 bars. When the evaporating pressure is above 3 bars, the valve is fully open and allows all the gas from the evaporator to pass to the compressor. When the pressure drops below 3 bars, the valve begins to close, allowing less gas to pass to the compressor. Consequently, more gas remains in the evaporator, causing the evaporating pressure to rise to the set point. Now, let's see how this valve accomplishes that. The inlet of this valve is connected to the outlet of the evaporator, and the outlet is connected to the suction line leading to the compressor. These two surfaces have the same area, and the pressure at the outlet cannot move the rod. The rod can be moved only by the inlet pressure. This valve consists of a seat disc, valve port, rod, bellows, closing spring, and adjusting nut. Now, let's see how it functions with an example. In this example, let's say the evaporating pressure should not drop below 3 bars, so the valve is set to this pressure. When the evaporator pressure is above 3 bars, the incoming pressure will cause the valve seat to rise against the spring force, which is set for 3 bars. In this state, the valve is fully open, allowing all the gas to pass to the compressor. However, when the evaporator pressure falls below 3 bars, the spring force will push the seat down, reducing the amount of gas passing through the valve. As a result, more gas stays in the evaporator, causing the pressure to rise back to the set value. Let's look at a practical application where an EPRV should be used. In this application, multiple evaporators are connected to a single refrigeration system with one compressor, but each evaporator requires different evaporating temperatures. A compressor can handle only one suction pressure, but in this application, we need 2 evaporating temperatures, resulting in 2 different pressures, which is impossible to achieve with one compressor. Therefore, an EPRV must be installed in the suction line of the higher pressure evaporator, while the lowest pressure in the system will be handled directly by the compressor. For this example, the refrigerant is R22, and the required evaporating temperatures are -25 degrees Celsius and -5 degrees Celsius. An EPRV is installed at the outlet of the higher pressure evaporator and should be set to the corresponding pressure for a -5 degrees Celsius saturation temperature, which is 3.2 bars. The EPRV will not allow the evaporating pressure to drop below 3.2 bars, so the evaporating temperature in the warmer evaporator will be -5 degrees Celsius. Meanwhile, the pressure in the colder evaporator will be 1 bar, resulting in an evaporating temperature of -25 degrees Celsius. Remember, in such applications, check valves should be installed at the outlet of the colder evaporators to prevent the migration of refrigerant from the warmer to the colder evaporators during off cycles. I hope this video was useful. Thank you for watching.